want to compute the Jacobian matrix, we've got this function given to us, so f of t is that. Let's do that first, and we'll get back to the second part of the question. Okay, what was the function? T cubed minus t e to the t. Okay, so the Jacobian matrix for the function. Well, this is the matrix of partial derivatives. Except here's the thing: there's only one input variable, so it's the matrix of derivatives. Right? Now, don't forget that each input variable corresponds to a column. So the fact that there's only one input variable here means that there's only one column. This column is made up entirely of the derivatives with respect to t. So we're going to have 3t squared minus 1 and then e to the t. Does that make sense? Okay. All right. Now, the question then asks, how does this appear to relate to the parametric derivative? So let's view this as a parametric curve and take the derivative. So I'm going to rename it, by the way, as x of t, because that's how we've written it in the past. X comma y equals. Now, of course, it's still the same function, t cubed minus t minus comma e to the t. And let's write down x prime of t. I'm going to write the vector vertically. It's the same thing, 3t squared minus 1 e to the t. Does that make sense? So the observation to make here, the purpose of this question is just to make the observation that when you're talking about a parametric curve, right, the Jacobian matrix is the velocity vector. Just it's kind of thought of as a matrix. And that's it. Does that make sense? Everybody happy?